Alright, then we go down here under the pipe system section, and here as you can see we have all kinds of items such as vents, which you can right click on and open up the type properties, and under the graphic override section you can click on edit and control the coloring of it. Now I can assign any color that I want to it. After that we have another section here called abbreviation, which can be extremely helpful to us because in your projects you may have a lot of different types of systems, but these Revit systems are fixed. For example, it has domestic cold water or hot water main, as you can see here, or sanitary, or etc. Now you may want to categorize these systems. You can give them an abbreviation and put it under this section here. For example, I can put in VE, short for vent, and then I'll hit apply and OK. Then as soon as you select the item, you can see under the system abbreviation setting, the VE is written. Now, where is this useful? There are a couple of situations. For example, you have different types of vents and you see vent 1 or 2. And if you actually remember, in the system browser settings, we have the same type of rows, for example here, for drain as well. But I may want to set the drain 1 and 2, for example, as DR systems. Or if you look at the detail here in the AutoCAD file, we have a good example for this right here. Here we have the coding called RL01 and RS02. And down here we have 5RD. These are the abbreviations that are used in the plan. These can be helpful to us in categorizing and distinguishing the different type of systems that we have in the plan. So keep that helpful tip in your mind as we progress. So now let's go back to the plan, and I think it's okay up to now. And I think I've copied a cut line over here. Seems not. So I'll get a copy of this and bring it down here and paste it. Then using the align tool, I'll select this and the cut line itself and connect them, and then I'll rotate the direction of the cut line, and then we can right click here and select the go to view option. Alright, now that we're in the detail, I'll just increase the size of it, and as you can see we have a couple of windows over here. Because of this, we have to move the pipes around the window and up. So I'll select this and then click on draw pipe, and then using a 45-degree angle, I'll go up, and then in order to prevent a collision here, I'll move this down. Alright, I moved it down a bit too much, so I'll go over here and delete this pipe piece that we have in the middle. Then I'll move the fitting lower and connect it to here. Alright, then I can reduce the size of the pipe and move it over here, and then using the draw pipe option, I can bring this up vertically. Now if possible, you can move it as well so it doesn't protrude into the window frame, and bring it to the right. Alright, so it seems like we may run into an issue, so we hit Ctrl Z and delete these two. Then we start drawing once again and making an outward angle. We can rotate this piece so we can be sure. I'll Ctrl Z because all of the system was moving together. You need to pay attention to these. So I can move the pipe over here and then select the draw pipe option, and then I can draw horizontally to the right of the window, and then I can go up. The reason that we're getting the warning is because there is little distance. So I'll hit Ctrl Z and put the slope on off. Then I'll start drawing the pipe once again, going to the right and making an angle and going upwards. Then I'll delete the piece in the middle and connect these two up. Then I can select the fitting over here, and using that move the whole system to the left. Now as you can see, the PVC item on the bottom is moving here as well. In situations like these, you can make a dimension over here and put in, for example, 40 centimeters and then lock it up. So when you move the system, you'll get a warning telling you that a piece is moving. And alright, now cancel on this, and then cancel once again, and it's fine for now. Now we just need to cover this part up in the joinery. Then I'll go over here and select draw pipe option once again, and then I'll draw the pipe vertically upwards to this point that is above the suspended ceiling. Then I'll go over to the plan, and as you can see, it's this part here that we're designing. Now I can use the align tool. Alright, we can select the center of this. So I'll create a reference instead, which goes through here vertically, and then once again use align to connect these two up. We just have to check the direction, and then we can right click and go to view. Alright, now in the detail 10 itself, we can enlarge in the size of the view, and then we can go over here and select this pipe piece that we have. Then right click on the circle here and select draw pipe. Now using a 1% slope value, we can go upwards and draw the pipe up to this point. Alright, then using the align tool, we can connect the center of this to here, and then we'll go over to the 3D view and we can see this area here. Now we can connect these two up using the trim tool. Then I'll increase the length of this and trim these two up as well. Alright, then on this we can select the circle icon and reduce the size of this, and then we can return to the plan. And here we can see the pipe that we're designing. Alright, then I'll select it and then bring it downwards a bit, shortening the length of it, and then I'll select the trim tool to connect it to the fitting that we have up top. Alright, and that's it for the vent that we have in this part. Now after that, we can go to the section box that we have, and let me just reduce the size of it by a bit so that we can see exactly where this piece goes. So as you can see, the pipe goes through here, and then we have the wall post here as well, which the pipe goes through, but it's still clashing with it, so we need to fix this as well. Now, one of the advantages of using wall posts is when we're drawing the pipes in a plan such as this one, and there are clashes happening with the vents and the canals and the ducts that go through the walls. As an example, you can imagine that a canal has to go through here and it needs an opening. The wall posts help us to resolve these issues. For example, when we have a drain like here, we need to do core drillings as well. These core drillings are expensive, just each one of them. Now, in a project, may it be residential or commercial, the expense of the core drillings pile up, and they'll add up to be even more than the spent sum on designing of the plans. Now, if you can control these core drillings and get them as sharp as possible, and if you can make the hole here before the concrete placement so that there won't be any core drillings later on, the money saved from core drillings is multiple of the amount of the money you're receiving for beam designs. So these have to be resolved with the contractor in order for them to accept the system and work with your plan. Fortunately, these are accepted today, but we still need to build the foundations of trust with the contractor or the company that we're working with. Now, these are separate, not even discussing the quality of your modeling or the time management and whether the plans are made quicker or they're neat enough. Even without discussing these, if you can justify the expenses that you save on the core drillings itself, because of the amount of the expenses saved, you can make a lot of the trust just in that topic itself. But for doing this, you need to have accurate fittings and placements. I mean, if you're, for example, 1 centimeter off, it may be okay, but 5 is way too much. You'll have to fill out the hole that you've made and make a core over there. Now, these are expenses of redoing. Or for example, the pathways themselves are messed up and stuff like these that you need to be careful about so that you don't make